Okay, we're going to do a quick review of laws of exponents, starting with the product rule. Remember, all of these laws only apply when the same base is being raised to an exponent. So notice x squared times x cubed. And it is best if those are in parentheses, by the way. So the product rule says that when you multiply powers of the same base, you add the exponents. And let's think about that. X times x looks just like that. X cubed looks like that. When you multiply those, that's 5 of those. So that's when you multiply the same base like that, the repeated multiplication becomes the exponent. So when you multiply powers of the same base, you add the exponents. When you divide, that's the quotient rule. The inverse of multiplication is division. The inverse of addition, adding fractions, is subtracting. So when you divide powers, you subtract the exponents. So here's a visual of that. So if you have x to the fifth, divide x to the third, well, look at what happens. And now what you have left is x squared. When you divide powers of the same base, this only works if it's the same base. If you did x to the fifth divide y to the fourth, you couldn't do anything with that because they're not the same base. All right. Then the power rule, when you take a power and you raise it to a power, you multiply. That's like saying here, I'll change this to the third. That's like saying x squared. So if you said x squared cubed, another way to write that, and now look at what we have. We have x squared times x squared times x squared. If you add all of those, 2 plus 2 plus 2, well, 2 plus 2 plus 2 is the same as 3 times 2. So when a power is being raised to another power, you simply multiply. So here I gave the example, x cubed squared becomes x cubed times x cubed, 3 plus 3. But a simpler way, if they're being raised to a power, you can simply multiply, which is what I did right there. So yeah, if you, inside here, let's say you had x squared, y to the 6th, z to the 4th, and this was all to the 5th power. Each one of these, because this is all multiplication in here. Now, if there would have been a plus sign in here to the 5th power, you would do something completely different. But if everything is being multiplied on the inside, then you can treat that as all 3 individuals as being raised to the 5th power. So x squared to the 5th power, y to the 6th to the 6th power, and z to the 4th to the 5th power. Well, and what do we say? When you raise a power to a power, you multiply. So 2 to the 5th is 10. 6 to the 5th, 6 times 5 is 30. 4 times 5 is 20. And this would be the simplified answer to that. Okay, so those are those rules. And here are some examples. 4 squared times 4 to the 5th becomes 4 to the, when you multiply bases, you add the exponents. So here's an example where you have multiple variables. X squared y cubed times x to the 4th y to the 5th. Rewrite it as x squared times x to the 4th, and then add the exponents. Y cubed times y to the 5th, add the exponents, and then simplify. 2 plus 4, x to the 6th, 3 plus 5, y to the 8th. Notice, you don't do anything with the exponents when the bases are not the same. You can't do anything. So what you could do there is 3 squared is 9, 4 cubed is 64, and when you multiply 9 times 64, let's see, you get looks like maybe 576. That's the most you could do there. You can't do anything with the exponents. Okay, example of dividing. 2 to the 10th, divide 2 cubed. Well, when we divide powers of the same base, you subtract. 10 subtract 3 is 7. And now, because this is a number, 2 to the 7th, so in your calculator, hit the caret button and then enter 7 and then enter, and you get 128. All right. When you're looking at, there's multiple variables, look at the same bases only. So x to the 4th divide x squared. The quotient rule is you subtract exponents. So 4 subtract 2, 5 subtract that invisible 1, and then it simplifies to x squared y to the 4th. And then again, notice if they're not the same base, you can't do anything with that. Okay, then there's 2 other rules I'm going to go by. Any non-zero number, meaning 0 to the 0, does not equal 1. But any number than 0 to the 0 power is equal to 1. Here's an example of why. If you have x to the 5th, divide x to the 5th. Well, look at, or let's say 5 to the 1st, divide 5 to the 1st. Well, 5 divide 5 is 1. But also look at, if you're dividing, these are the same base, well, 1 subtract 1. Remember, when you divide powers of the same base, you subtract. Well, 1 subtract 1, and 5 to the 0 is equal to 1, because 5 to the 0 means that whatever that number was, you divided it by itself. And any number divided itself is equal to 1. That's what that 0 means. So if you had a bunch of stuff in here all multiplying, x to the 12th, y to the negative 3rd, z to the 5th, to the 0 power, right there you can automatically just jump to that's equal to 1. There's an example of it right there. Okay, and then negative exponents. Negative exponents simply mean write reciprocal. Write the reciprocal. So if you have x to the negative 1, you can rewrite that as 1 over x to the positive 1. X to the negative 2, 1 over x to the positive 2. So 10 to the negative 1, 1 over 10 to the 1st. And notice when you rewrite it as a reciprocal, the exponent is now positive. Now, the converse is true. If you have 1 over a value with a negative exponent, and I didn't write that, look like it. That's a negative exponent. So it flips, and it now becomes y to the positive 2 exponent. We'll do standard and scientific notation in a different video. All right. Properties of exponents.